So if we have to talk about units of heat, so we know that heat is a form of energy and energy is measured in joules because work done is in joules, and I have already stated you this long time before that work done is equivalent to energy stored in a body. The amount of work performed by a body will be equal to energy stored in it. So they are interrelated. So the SI unit would be joules. So you can define joules by any formula you would like, from mgh, from half mv square, from anywhere. Okay. There is another CGS unit of heat which is called calorie. So calorie is basically amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. There the temperature is basically from 4 degrees Celsius to 5, or from anywhere you can actually, it's not very huge difference unless and until we are talking about very specific observations. There is not huge difference if you take the temperature of water from anywhere to anywhere. So 1 calorie is basically heat required to raise the temperature of 1 gram of water by 1 degree Celsius. This is the calorie. Now, if I also want to know what are the factors involved if I have to give heat to this body, suppose there is some body and I want to give it heat. Heat and energy will be represented by term Q. So, heat, if I have to give it to some mass, suppose I have 10 gram of marker. So, heat given will be less, but I have 10 kgs of marker, obviously heat provided will be more, because heat will be directly proportional to the mass which is absorbing the heat. So this gives me that heat provided to any body is directly proportional to mass, first of all. Now, second part, heat will also be proportional to change in temperature required. For instance, I want to raise the temperature of this marker by 1 degree Celsius. So this can be done by even by some small heat, but if I have to change the temperature of this marker by 50 degrees Celsius, so a large quantity of heat would be required, obviously, right? So more the amount of heat, that means more will be the change in temperature, or vice versa. If we require more change in temperature, we'll be requiring more amount of heat. So heat is also directly proportional to change desired in temperature. Okay, so change in temperature. Lastly, equal amount of or same mass of different substance will take different amount of heats to raise its temperature by same quantity. What I just said was, suppose there is a quantity A and there is this quantity B. Let's take an example. Let's say the quantity A is iron and let's say quantity B is salt. Okay. Now we have taken 10 grams here as well, 10 grams here as well. So do you think, don't think right now, suppose the temperature right now is 15 degrees Celsius here as well. Now think, do you think that heat required to change the temperature of iron from 15 to 20 degrees Celsius will be equal to heat required to change the temperature of salt by 15 to 16? No. Heat quantity required will be different, because same amount of different substance will cause or will accept or will liberate different quantities of heat. So we now know that there is some external quantity involved here which also specifies the type of or nature of mass which we have taken. So that is why we are taking a new term which is called specific heat capacity. So before proceeding further, I would explain to you what is specific heat capacity. It's a very simple thing. Specific heat capacity of any substance is equal to amount of heat required to change its temperature by 1 degree Celsius. I would repeat, I have missed a point which is called unit mass. So I would repeat, specific heat capacity, you can write it down now, is the amount of heat required to change the temperature of unit mass of a substance by unit degree Celsius. That means you take the substance of 1 gram or 1 kg and change its temperature by 1 degree Celsius or 1 Kelvin, they are the same thing. Then the heat required or heat absorbed will be called specific heat capacity. So the notations here are: mass is m, temperature delta T, Why delta T? Because this is change in temperature. Delta T is, in simpler terms, is basically T2 minus T1, final temperature minus initial temperature, because we are talking about change in temperature. We are not talking about initial and final temperature. Lastly, specific heat capacity is denoted by term C. So Q, the formula from the above observation is Q is equal to mc delta T. This is the main formula for calorimetry, and we are going to use this formula again and again. So total heat absorbed by the body is product of mass, specific heat capacity and change in temperature.